Hi and welcome back to a new video. PC Games Hardware, which is a German media, recently published a CPU custom water cooling test, and they also featured our Delta-made MP2 CPU water block, and the conclusion about this was pretty negative. And a lot of people sent this test to me, and then also I saw in the comments that people were requesting a statement from my side about the criticism that PC Games Hardware had against this product and also its performance. So that's what we will do in today's video. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comps included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. The video of PC Games Hardware is unfortunately in German, so it might be a little bit difficult to follow. I will still put all the links in the description. We will go over the individual criticism points after each other. There's also a second link I would recommend if you can watch it, and that's the first one they published a couple days earlier, where they just showed the test setup. The test setup is quite cool but also simple. It is based on an AMD CPU with 200 watts of load. And they basically measure the delta of the water temperature to the CPU temperature, and they take multiple measurements and then take the average. What I personally find quite cool is the approach of limiting the flow rate. Just use a vise, clamp the tubing in between, and then just compress it as much as needed. That is a quite simple but very effective method. I will definitely also not pull this typical vendor move of, oh, there's a test I dislike, let's criticize the test setup or the parameters, because that's what I personally really hate as a reviewer. As a reviewer, you can test your product the way you want, right? You set your own parameters or your own boundary conditions, which they set as using an AMD CPU under load with 200 watts. And as long as you can repeat this every single time, that's absolutely fine. There is no correct or wrong testing as long as you do it structured in the same way. Because you just set your own parameter, and this one is 200 watts of an AMD CPU, and that's fine. That's one scenario. This review mainly focuses on the new Heatkiller 5 by Watercool and our MP2. We're straight jumping to their testing results, so the temperatures. As I said before, they are taking the temperature difference between the water temperature and the CPU temperature. And if we look at the Heatkiller 5 by Watercool, it's 41.8 degrees Celsius and the MP2 has 44.4 degrees Celsius. That means that between the main tested CPU blocks, that's the Heatkiller 5 and our MP2, under full load, there's a temperature difference of 2.6 degrees Celsius. And the main criticism by PC Games Hardware is that this should perform better, like probably the same performance as what they measured with the Heatkiller 5, but that's probably physically not quite possible. One of the reasons is coating related, and for this we're just jumping in this small section of the video.
Das hier ist im Gegensatz zu dem kurz vor Redaktionsschluss gekommenen vernickelten Teil, den Kühler, den ich tatsächlich getestet habe. Ihr seht schon, wie gesagt, der wurde fertiggestellt, bevor auch nur die Vernickelung erfolgt war. Das heißt, ich habe hier das nackte, blanke Kupfer bei der Bodenplatte, noch fingerabdruckempfindlicher und auch bei der Zwischenplatte. Aber auch das wieder rein optischer Unterschied, genauso wie das leicht andere Halterungsmaterial, die Schrauben waren auch noch nicht final. Auf die Kühltechnik und auf die Handhabung hat das alles keinen Einfluss, weswegen.
Thorsten from PC Games Hardware received the block from Watercool as a prototype, and they received an early sample which was not coated. He then says that this does not matter and that the coating is purely just design, but doesn't impact the performance. Maybe you remember this video that I shot about 2 years ago, where I showed how much we had to learn regarding the coating and how much it had impacted our performance regarding direct die. Of course, the impact regarding direct die is much bigger and much more relevant, but even on a normal CPU block, it has an influence, especially if you're looking at such small temperature differences. I also have two examples here. One is nickel coated, one is not coated. And on the MP2, we are using a 20 micrometer thick chemical, so electroless nickel plating. 20 micrometers is quite a lot. You could also go, for example, with 5 micrometers, which is better in terms of performance. But with 5 micrometers, you're not having sufficient corrosion resistance because there might still be some porosity of the layer if it's only that thin. The second reason why we have to go for this nickel layer is because a lot of our customers are using liquid metal as a thermal interface material. And we know we had to learn over the years a lot with liquid metal that if you apply liquid metal directly on uncoated copper, you will have intermetallic compounds forming between the gallium and the copper. That is what you usually see as dried liquid metal. It's just those intermetallic compounds. But they are causing bad thermal transfer, and you would have to reapply it, and it will not be as good as before. And because we have to kind of fight that, that's why we have to go with nickel coating. I also want to show you this internal chart that we used while development. And there we can see the MP2 also versus other products. But for us, mainly interesting was our own cold plate design. This is also quite similar to how PC Games Hardware was testing. We were using a 9900X with 230 watts under load. And if we just look at those specific two examples, this is the same cold plate but coated versus uncoated. And you see a temperature difference between 1.6 to 1.8 degrees Celsius. 20 micrometers, just as a number when it comes to the nickel plating, might be difficult to digest. It's 0.02 millimeters. And that doesn't sound a lot. But if you're going in the region of talking about 0.1 or 0.2 millimeter fins or like channels, then this can become a lot, because you might not realize, but it's not only the bottom that's getting coated, but also the fins that you're coating. So just showing you under the microscope, it's quite easy to measure here. It's the same as we advertise. You can see we have a channel width of 0.2 millimeter, and also the fin itself is again 0.2 millimeter. Now the nickel plated part, and there you can see quite a difference. Even though this is the same milled part, so it was also 0.2, 0.2 before, but now plated, it is 0.24 on the fin, and the spacing in between the channel is about 0.17. So you can see that it definitely has also a physical impact just when it comes to the coating. You can also visually see it, and that is then definitely causing a change. You will have different flow rates through the channel and also different temperatures that are caused by this. It's also quite interesting now that I think about it. Of course, we mill this thing, right? It has 0.2, 0.2. But then we plate it, and then the dimensions are different. So that would probably also mean we should change our product description, because it's no longer 0.2, 0.2. So that probably has to be updated. I have to think about how we phrase that, how we just educate about this entire topic. And just not only the geometrical, but also the performance part is one of the reasons why we decided, as you've seen in a couple of videos ago, that we want to go to the PVD coating in the future, because those PVD coatings, they can be a lot thinner to achieve the same kind of corrosion resistant result and also be much better in terms of just performance. But the point I was trying to make here is that you simply can't tell that this is the same. You can't have the claim that, oh, you tested an uncoated block and the coated one will perform the same. They will not perform the same. Even if you just coat this by 5 micrometers, if you look at the tiny channels, it will have an impact, at least on the flow rate. The impact might not be big, but we're debating 2.6 degrees Celsius here, so then we also have to take all the small things into account. But I also want to stay absolutely realistic here, that even if we would offer this as an uncoated version, it would not be able to match the Heatkiller 5 in the current state, because there's just too many compromises we had to make in order to achieve the design I wanted to have. On this block, we have this big borosilicate glass window, which is a material I just personally like. I'm not a big fan of acrylic, so I was trying to avoid acrylic at all costs. But that comes with downsides, a lot of downsides. One is that we just can't mill this like acrylic. In an ideal world, you would have the inlet just in the center, so it could directly hit the fins underneath. But obviously that's not possible. We can't mill the glass. So we have to make compromises. The compromise is that this is the inlet. It goes down, it goes to the side, and then goes up in 2 directions and then enters the channel in the center. And that's just flow-wise not optimal. It would be much better to do it this way. This is an unreleased prototype. It's the stainless steel version, uncoated on the bottom, and it has the inlet directly in the center above the structure. So that's more optimal, but in this version, for example, we wouldn't be able to make this with borosilicate glass. We're left with a compromise in the end that I was willing to take, that I'm still willing to take, because I wanted to achieve this design with the specific materials being used. and we just can't have the direct inlet from the top into the structure. That's not possible with the glass. We can't cut the thread into the glass, and we will lose like a degree Celsius by the water having to go this extra route and then not being able to hit the structure perfectly from the top. Next big criticism was mounting and manual.
Viel mehr gibt es dann aber jetzt eigentlich auch nicht zu sagen, weil es ist auch wieder nur ein Kühler, der von oben auf Sockelarm 5 geschraubt wird. Und ja, was soll man dafür beilegen? Nun, Vorschlag 1 wäre mal eine vernünftige Anleitung oder zumindest selbsterklärendes Halterungsmaterial.
Manual confused me a little bit, to be honest, because it's included, and also you could see how it falls out of the box when he opens this. The manual is also available online as a PDF, and it's detailing all the individual steps also in 10 languages. And it starts with this explosive view that is detailing almost every single part except for the washer. We're getting to this in a second. And it's then showing you, for example, step 3, remove AMD's mounting, step 4, add the standoff, and so on. Just from my own personal experience, I mean, that's how we ended up with those kind of explosive views. I like to look at these, and then I can easily just realize how this is built, and I can mount it easily without even reading anything. But maybe that's even the wrong approach. I'm not sure. Maybe you can give me input about what you think about this. Would you like to just have one of those explosive views, or do you actually want to see something very detailed, maybe like 7, 8 pictures, step by step with like extended written guides how to do it? Please let me know, and then we would absolutely do that for the future. Yeah, and what we will also do for the future for sure is whenever we have a product launch, then just have a video manual as well. So just upload a video on our Thermal Grizzly YouTube channel where we then explain how to mount it. I think that might be even easier than just reading something. Thorsten also criticized that those tiny plastic washers are not detailed in the explosive view, and that's absolutely correct. We kind of forgot about this, but we also didn't make it in time. So these were added in basically last second. We added them when the product was already done because we realized that adding them on those nuts in between the spring and the nut just makes your mounting experience much better. It just feels better because there's less friction between the spring and this metal part. But we then didn't add them into the explosive view, or I think at that time we actually had the manuals already printed. So that's why they are missing, but we will definitely change that. Additionally, Thorsten then criticizes that there are no details in the manual regarding to how much torque you should use when mounting the screws, and that there is also no stop, so you could mount the screws all the way down to even fully compress the spring and then apply too much mounting pressure. The criticism is absolutely valid and correct here. It should have been detailed to how much you should tighten the screws with what kind of torque and to what degree, and we definitely missed that. We will add this into the manual, at least the PDF one. There are already some of the products floating around, so the ones that are floating around or were already sold obviously did not have this detailed, but we will add it in the PDF and then add it for all the future ones that we will order in terms of the manuals that we will order. He also complained about that there is no stop regarding the mounting system, but that's actually intentional. Right now there is no direct diversion of the MP2. That is because it is quite difficult to keep this design language and make it direct die compatible. We're still working on this, but it's far from being done. So we still have a couple of customers that want this design but want to have better performance. Also better performance than what you would get with, for example, the Heatkiller 5. That would be going direct die, deleting your CPU. And you can have, again, it's a compromise, but you can kind of do it if you use the high performance heat spreader, delete your CPU, use liquid metal, and then mount the MP2 on top. But those high performance heat spreaders, they are sitting about 2 millimeters lower than the original AMD stock mounting height. And in order for the block to be able to account for the 2 millimeter difference in mounting height, we could not implement the stop. So that's why it's intentional. It's not a mistake that there is no stop to keep the mounting height. It is to make it compatible, if needed, also for direct die, because we simply have a couple of customers that want to combine our products, and we have to make sure that our products are compatible.
Und der zweite Fehler, der mir dann nach dem Test auch aufgefallen ist, ist diese Stelle hier. Ich erkläre kurz mal das Prinzip. Der Einlass sitzt hier. Das Wasser muss dann erstmal, weil es ja nicht direkt durch das Echtglas von oben auf die Kühlschrank, wird es erstmal in diesen Kanal hier zur Seite geleitet, fließt dann auf der Vorderseite parallel rüber und dann mittig den Schlitz nach unten. Das heißt, das hier ist alles Einlass. Hier kommt das Wasser dann raus auf die Bodenplatte, breitet sich in der Bodenplatte aus und hier ist Auslass, der zu den Kanälen führt und dann zum Gewinde. Das heißt also, hier haben wir die Niederdruckseite des Kühlers, wo das Wasser abfließt. Und hier haben wir den Hochdruckkanal, der zum Kühler hinführt. Und ihr seht, wie viel Dichtung dazwischen? Keine einzige. Das sind knapp 2 mm Metall auf Metall. Bei GPU-Kühlern hat man sich das schon vor Jahren abgewöhnt, so zu bauen, weil man einfach die Sachen nicht so fest aufeinander pressen kann, dass das 100% dicht ist. Da geht immer ein Teil des Wassers vorbei. Und ich vermute, das ist auch wieder ein Grund, wo Thermal Grizzly hier Kühlleistung liegen lässt.
That part is actually rather difficult. Because obviously you can take the assumption that this might be a problem, that there might be an O-ring missing and there is some, like, I don't know, cross-flow or how you would call that, it would negatively impact your performance. But the thing is, he does not test this claim. He just claims it and then says it's a big problem without testing it. The thing is though, we tested this and I can also test this again with you. To test Torsten's claims, I decided to take one of the MP2s and I used a piece of acrylic and glued it into the inlet. So especially if you take a look from this side, you can see the inlet side is fully blocked. So just a piece of acrylic, added some super glue and then waited until it was dry. And that's it. So the theory is now I add a strong pump to the inlet. The water would go inside here and build up over the inlet, but it can't go through. So the only way it could go through, at least according to Torsten's theory, is by just crossing this small path right here. And everything else, like here, is the inlet water that would build up with high pressure. So following Torsten's theory, it would go over here and then just go out on the outlet port. That is our quite simple test assembly. We have a DDC pump with some water in the reservoir. And if we're following the theory from Torsten, then if we would switch on the pump, then everything would just directly go through the block because apparently we're missing the O-ring. I just connected this to the inlet of the water block. And as I showed you before, the water block structure is fully blocked by what I added in there, which means that if we're following the theory, the only way the water could go through the block now is by going through this area that is not sealed off correctly according to PC Games hardware. So that's what we're discussing about. I also want to highlight that this is an extreme example because we're fully blocking the entire structure of the block, which means that the entire pressure the DDC can build up is inside the block and is working against the not sealed surfaces. But you could see even in that state, like the absolute worst case scenario, you have those few drops coming out of the block and that's it. But in a normal realistic condition where you're just running your normal flow through the block where the structure is not blocked, you don't have the pressure building up that much. So there will be no water like going from through that will just not happen. So adding an O-ring in that would not change anything performance-wise. It should also not be underestimated how this is built because you have two flat milled copper surfaces and then you have 7 screws M3 with countersunk heads and then they're tightened with 1 Newton meter, which is quite a lot. And then you can calculate it. It depends on what kind of friction values you use, but it could be roughly 5 kilonewtons of just pressure in between those two plates. That translates in you would put 500 kilograms on this face right here and press the two plates together. That's what you're left with. And because it's just 2 milled copper surfaces or like copper and brass, there is not much going on in between. Like there is no space of a lot of water flowing around. That's not happening. Obviously it's not airtight, but you can also see that even water with like what we tested, it's just a few drips that can go through in the absolute worst case, high pressure theoretical case. What I would like to offer to PC Games hardware is just to send an uncoated cold plate to them, because that's also personally interesting for me to see in their test setup what would be the temperature difference. And I think that's also relevant or would be interesting to a lot of other viewers out there. For the criticism around the manual and documentation, absolutely valid, and I will make sure that we change that for the future. It should be more detailed, it should have been more detailed, that like the mounting height is more detailed, that what are the different states that are available when it comes to how you can mount it in different heights, what kind of torque you should use, and all these kind of things. With the washer, we will make sure that all of this will be better for the future. Regarding the, I would call it performance drama a little bit, because The way he says it in the video is almost like this is an unusable product. I don't really agree that much because, you know, it's 200 watts load scenario, and there we are left like the market leader, like Watercool. They are so superior when it comes to knowledge and just manufacturing and everything. They have been in the market for 27 years. We entered the market the first time for a normal CPU block 4 months ago. And if I'm like 27 years versus 4 months on the normal CPU cooling market, and we are 2.6 degrees Celsius away, that's, from my perspective, not too bad. So we definitely still have room for improvement, and we want to do that. We know that there is room left in the coating for about 1 degree Celsius. That's where we want to use PVE for the future. Then we would be left with 1.5 degrees Celsius difference. And then it's just a choice if you want to go with this design or if you want to have something that's purely performance optimized. But from my personal perspective, if this 1.5 degrees Celsius matter, then you should go direct die all the way. Because like 1.5 degrees Celsius don't give you anything, but if you can optimize it by 10 to 15 degrees, which is what direct eye will give you, that's where you could, for example, get 50 megahertz when you want to do overclocking. But yeah. Hope you enjoyed this video regarding the statement that people requested. I hope that's fine. See you next time. Bye-bye.